Hey folks, we are doing our first dive into the data model and tackling the biggest, scariest table of them all. We are going to be looking at the element table, which is at the core center of our data model. It's so long that it doesn't even fit into Power BI's maximum size for the tables here. So this is going to be foundational, and it's going to be a table you're going to use in every single report. Now, before we dive into it, I want you to go on docs.vimaec.com. And in here, you'll notice that you can go to the bottom. And in Vim for Power BI, we're going to have a document here that is the data model reference. Now, there's an introduction to here, and it says that we recommend learning the tables in the following order. So the first thing we should look at is the element table. And there's going to be basically a description for everything in here. So if you don't necessarily want to go through the entire video format, if you want to have a reference for later, I recommend that you maybe bookmark this page or at least have a look through it if something I say in the video is perhaps not clear enough. So as we can see here, the element table is really a mixture of physical items and conceptual items. So everything that you count in Power BI is generally going to be from the element table. And we can look at some of these columns. It's going to give us an idea of what is in here. So for example, the element type will show us that the element table contains things that are both physical and conceptual. So we have things like levels, materials. You know, nobody's building a material, nobody's building a level. We have things like face filters, systems, rooms, 3D views, everything is in here. All the concepts are in here. And then of course, all of the physical items are in here as well. So you have ducts, you have conduits, you have ceilings, etc., etc., etc. So we're going to be able to filter quite easily what's a concept and what's a physical item, right? That way your list won't contain a kind of fruit salad of both of these. So let's just do a little analysis. There's some data that we can start kind of mentally discarding, and that's going to help us make some more room for the data that's important. So notice in here, in the element table, we have a folder called external keys, and notice how they're also all hidden. That means that if I go into the report here, I'm not going to see them. There's no folder here in the element table that says external keys. And when we look at this table here, we see all of the keys, they're hidden once again. And what that means is these are connections. So that means if we want to know, let's say there's a floor in the element table and that floor is on a level, well, the instance level key is probably going to say, let's say number 1. And then when we go to the connection of the instance level, well, the key is also going to say number 1. That's how they're associated. And then we're going to have access to all of this extra information in here that we wouldn't have otherwise. So if we highlight in the model view, if we highlight these connections, if they're visible, they're going to show up. So here it says instance level key, and down here is going to point to the key. Now, just to get a little bit nerdy, when this is not the case, like see, for example, element view, right? So a view has multiple elements. It's not a one-to-one relationship. Therefore, let's say there's a view number 1 and it has 100 things from the element table. It's going to have 100, it's connecting through the element. So there's going to be 100 lines. And every time when you look at that element, it's going to point to the same number, which is the key in the element table. So when we select here, we see element to key, element to key. So those are basically the two ways we do most of our connection: an element to key or a key to another key. So for example, here, the instance level key goes to the instance level key without that name in front of it. So that's really the crux of all of these connections, and you can kind of reverse engineer them by simply clicking on here to see what's going on in your connection. So compound structure key to element compound structure key. Pretty simple if you know how to deal with the information and the interface. Okay, so what does that mean? That means that all of these things here in this little folder called external keys, they're all hidden. You don't need to think about it ever. It's part of the setup. Forget about it. close this forever and banish it from your memory. All right, now on to more pleasant things. As you probably remember from previous videos, the elements in here, all of the columns in here are alphabetically sorted and they can be in folders, and this really helps organize everything. However, in here it's kind of a mess. It's just the things on the left are the first things that were loaded in the database, and the things on the right are future things that were calculated or added to the database. So there's no alphabetical order here. There is structure in alphabetical order here. So we're just going to go one by one from the right side of the column. Okay, so keys is probably the most crucial concept that you need to understand. Every key is unique. Therefore, if you want to count the number of floors, you count the number of keys. And there's a very crucial difference between counting and summing, right? Counting is how many of these different values are there, or how many values are there, right? So for example, 1, 2, 3 values, or let's say rows, versus summing would be 19,000 plus 19,000 plus 19,000. So that's not 3 floors, that's like 60,000 floors or something like that, right? So we want to count keys, and because keys are unique, we don't necessarily need to do a count distinct. So in here, when we look, it just says count. If I change it to count not distinct, it's actually going to be a bit faster. It's a more complicated operation to count and make sure things are distinct, but it's not really that super important. Just know that generally we count keys, we do not sum them. Like, let's put this to sum, look at the numbers, they're crazy. That makes no sense. So in this case, because the keys are unique, we can count or count distinct, and it's going to give us the same values. But because they're unique, it's a bit faster to just count. Okay, back in the data. Now the combined Revit ID, that's actually a measure, which you can see here. And it's a pretty simple but useful measure that looks at all of your selected Revit IDs and makes a list separated by a comma. So this is a measure. It's not really like a solid column in here. It's more like an addition to it. So we're going to skip it for now. The element index, we're also going to skip. You can look at the documentation. Basically, if you start merging databases, which is not something we do anymore very much, but if you start to merge them, the element index would remain unique keys, whereas it's possible that some of the keys would be not unique. So this is very much an edge case. Don't worry about it for now. Okay, we're really looking at list of elements here, and there's something we need to differentiate, which is the difference between an element and an instance. So everything in here is an element. Everything's an element. However, things that are instances have more information. And instances are basically physical items, right? So the concept of a material is an element, but a tape measure or a floor or a column exists in real space. In the programming world, we say instanced. It has been born. It has been birthed in the real space. So as soon as you are instance, now you start having more data to you. You start having perhaps a level. Perhaps you start having a material. Perhaps you are in a room. Perhaps you have a work plane, and so forth. So everything in here is going to have element data, but not everything in here is going to have instance data. This is basically the way Revit gives us the information. So we're just trying to make the best out of the mess that is being served to us and make things as easy for you as possible. Just know that there's some information that is sometimes only contained in the element or in the instance. So, a bit of a pain, but what are you going to do? Now, let's talk some more about the element name. And the element name is a bit of a weird one. It's basically actually quite useful. You should use it instead of family name. And the reason is element name is the family name, but it's also the room name when there's a room. So if you just go family name and you make a list of rooms and things that are not rooms, well, you're not going to have the room name. Whereas if you use the element name, you're going to have the list of the family types and you're going to have the list of the rooms. So let's look at an example here. We have a list of elements that are physical. And so we're going to want to see, for example, the name of the type. That's the name of the type, or the element name in this case. or it could be the element name, but right now we're using the family type name. And when we look at the rooms, well, because we're using the family type names, it's not going to come up with a room number. So how do we solve this? We use the element room instead. And now look at this, we have the names of the rooms. Ta-da! So the other thing is when we go back in our list here, well, see, this is the family type name. This is the element name, whereas this is the family type name. Useless, doesn't give us any information. And this is the element name. So really, try to use the element name. I mean, it's not as obvious, right? But if you're going to be making a list of room names, you're going to need that element name. And if you're using, the list of family names, if you want the list of family type names, well, the element name is going to answer that anyhow. So once again, I'm sorry, that's just the way that Revit gives us the data. We try to fix it as much as possible, but you can only make so much gold out of mercury. All right, now here's another important concept, PBI case sensitive. This is extremely important, and you're going to see it quite often in all of these values. That's the other thing, right? If you can't find a name, you can always just search it up here. I don't recommend doing this all the time, but it can be good to understand where things are quite quickly. So Power BI is not case sensitive by default. And this is a big problem because case sensitivity matters. So what I mean by case sensitivity is the capitalization that you use in these names. So for example, Power BI, if you were to give it these 3 differently spelled names of Apple, it would all transform it to the first one that it found in the list. So that's terrible, right? Because if you write Apple like this in 3 different ways, and I'm the BIM manager, well, those are not the same values. You did a huge mistake in your BIM model or the way that you named your face filters or something like that. So to truly, and this is just a really annoying behavior from Power BI, where frankly, we probably spent about 8 months solving this. It was a huge technical problem, and I don't think our competitors have really done any work in that regards. But the case sensitivity is going to allow you to make that difference. So here we have the case sensitive value for parameters, and we see it's not written the same. These 2 values are not the same. If we were to use the regular column, it would just merge them together. So the advantage of the case sensitivity column is that it's accurate. The disadvantage is you can't actually search case sensitive values, and you can't slice by them. So when you do a slicer, when you're searching, you have to search with this column. But if you want the proper data, you have to search with this column. I'll probably do a video just on this topic eventually. Just know that when you use slicers, you want to use the regular element name in this case, but when you want to make sure that you don't have 2 families with kind of weird spelling, you probably want to use the element name case sensitivity. And I'll probably do some reports that just look at that particular problem in the future as well, in all the places where it could arise. And I know this seems a bit weird to understand. Like, what do you mean I can't search? What do you mean I can't filter using these values? Like, let's try to type in the search grading in here, right? So I'm just going to write grading, and it can't find it. The reason for that is because there's invisible characters that allows that case sensitivity to happen. So while it looks like it just says grading, there is invisible characters in there through our technical magic that prevents it from being used as a slicer, prevents it from being searched. So enough on this topic. I'll make another video just to dive into this weird little quirk, and we'll move on to the next column. So the next column is the Revit ID. And I recommend that you use this to associate with external data like Excel and so forth. Just know that when you have multiple links, your Revit IDs can be present in other models, maybe like 0.2% of the time. But if you have 5 million elements, it's possible that there's like 5 or 10 of those elements that have the same ID in multiple models. The simple solution to that is to make a combination model name Revit ID. Okay, now the element type, that's not your family type name. That's just an internal categorization of Revit of how it names things, right? So we don't actually call wall sweeps with no spaces. So this can be useful, but it's not the same thing as the family type name. It's just the way that Revit sees it internally. So I wouldn't necessarily use this other than for troubleshooting and understanding what's happening. Now, the unique ID, you don't really, I wouldn't recommend using that. First off, it's not much more unique than the Revit IDs. You can still have duplicates across models. It's super long. And when you go in Revit, well, you can't select anything unless you have the Revit ID. So sure, if that's the way your data is coming in and you needed to connect, that's the only key that you have to connect to your external data, go ahead and use it. But generally, if you have the option, just use the Revit ID. It's shorter, it's more useful, and it's less data, it's less long, right? Okay, so we already saw we were going to skip over the external keys because they're, not really that useful anymore. So we're going to go right into things that are instanced, things that are actually in the space. And so here we see is pinned. Is it pinned? Yes or no? This is how you know what is pinned. So it's pretty simple. Probably you want to check if your main floors, your columns, your grids, your levels are pinned. This is going to be the same value, except that the difference is that instead of being a true or false, instead of being a Boolean, here we have it as text. So it's nicer to put in a list. It's more human readable. Notice when it's text, it goes to the left. And when it's a Boolean, there's a bit of an italic and it goes to the right. This is just a little bit of a UI thing. You can ignore it for now. You're probably not going to need that anytime soon. All right, here we have the instance constraint base. Notice the table is empty, and I could scroll down, but there's a lot of items in here. What I can do is I can click the down arrow here to see what kind of data is in here. Frankly, this should have been a number pointing to a table, or actually it could have been just a regular parameter. I don't really see a reason why these columns exist. I may just remove them in the future. All of this information is present in the parameters, and this is only going to be relevant for things like walls and so forth. So, I'm kind of self-auditing right now through this video. But, if it's useful for you, go right ahead. Okay, this is another, actually, I think this is a calculated column. And it's basically telling us whether that element has materials or not. So things with no materials will say no, things with materials will say yes. I'm not actually quite sure what this icon means, but the naming is pretty clear. This is going to tell us which elements are assigned to a room or not. So if you want to have a list of everything that's in a room versus everything that's not in a room, well, you can use this as the differentiator. And the instance work plane is going to tell us the work plane. So sometimes that's a level. Now notice here, if you are hosting on a work plane, or if you're hosting on something that's external, it's not going to be able to give you much information. It's just going to say, hey, listen, all I know is that you're linking on the name of this model, and that's all I know about it. All right, and finally here we have the differentiator isInstance. So this is going to be a 0 or 1. And generally, physical things are instances and conceptual things are not instances. There are some weird anomalies that can happen, however. So for example, if you are in Revit, I saw this example before. If you're in Revit and you make a 3D view and you hide everything except the doors, so your 3D view is just doors. Now Revit is still keeping things that are physical yet hidden in the list. So for example, it's going to keep a list of all of the walls that those doors are hosted to, because it wants to keep the relationship. It says, hey, you got 10 doors here, but every one of these doors is in a wall. So I'm going to keep the list of the walls, which are normally physical items, but they're not really there. They're going to show up in your list, and then you're like, well, what are these walls? I don't really care about them. And it's like, well, that's the parent to your door. And so if you want to hide this weird kind of leftover of the physical world that is hidden, you can hide things that are not instances. So if ever you have these weird anomalies of things that shouldn't be in your list, try to filter by saying, hide everything in here that the instance is not a 0. So let's do that right now, just so you know what I'm talking about. So in this list here, I'm going to drag this into the filter page, and I'm going to say, show me only the things that are number 1. So I don't think the number changed. So we're looking at only things that are instances. Let's see if we get anything if we write 0. Oh yeah, so here are things that are not instances. Oh, actually, this is a good one. So see this wall here, I know about this wall. It's a wall within another wall, and inside of Revit, there's a function of like merge, like get rid of like merge these walls together. So basically there's a wall, and then there's another wall, but this one's getting eaten. So it's there, but it's not physically there. It's kind of like in limbo. So that's why this single wall is not an instance, but it falls under the category of physical. There's also some other thing that is really helpful to do with the isInstance toggle. So let's say I create a list of all my categories in here. I'm just going to go category name full. And now I have a list of all my categories. And if I click on ceilings, I'm going to have the list of ceiling. Now, notice in here, there's a bunch of stuff that is not in our models. We don't have abutments. We don't have bearings. There's no bearings in this model. So it's just giving us a list of everything that could be in the model, of every single Revit category. So what we can do with the isInstance is we can drag it in the filter for this visual and then say is1. And so now our list here of categories only includes things that are in the model. Because it's for every one of these categories, it's going inside of the list and it's saying, well, I don't have any ones for abutments, so get rid of that. And so when you have a list and the list is too long and you want to just limit it to what is actually in your model, you can say filter it by isInstance is equal to 1. And this is going to make your list a lot more palatable and short and useful. All right, so we've gone through the instance table. Congratulations. Now the reference data is actually kind of a cheat sheet. It prevents you from having to go into other tables. So in here, we have the BIM document name, we have the category tag, we have the category full name, etc. We have work set. All of these are very useful. So let's go duplicate the Explorer, for example, and I'm going to delete a bunch of this stuff, and I'm going to create a new matrix here. And this matrix, I'm going to only use the elements from the reference data. So I'm going to say, well, first off, I'm going to count the keys. We always count the keys. Then I'm going to say, show me which BIM document it's in. Show me the category tag. Show me the name of the category fully. Show me the family name. Show me the family type name. Actually, you know what? We should probably use the element name. Remember what we said at the beginning of this video? Oh, and here's the work set. So I'm going to put the work set right above the category name. And so now we've used fully our reference data. And we have everything that we want in here. So this is the name of the architectural model. This is our category tag, which tells us if something is physical or not. And actually in this report, we have a lot of filters on the category tag. So let's get rid of these. Bloop. Now, we start to see a lot more stuff in our model. And then we have the category name if it exists. So category tag, work set, category name, family type name, and then we could even drag in our Revit ID down here. And now we have our beautiful hierarchy. So this cheat sheet, this reference data allows us to do this wonderful explorer, and this is going to be kind of core to all of your reports, right? This is generally how we look at information. And we may want to say, hey, you know what? All I care about in here are rooms, or all I care about in here are physical items. And all of a sudden, well, you know, it only shows the physical things, so we can just get rid of that's the category tag, so we can get rid of the category tag. And now it goes to the work set. Maybe we don't need the work sets, and all of a sudden we see the model and the categories, and you know what, maybe we don't need the BIM models, maybe we just go right to category. But as you can see, that's the bread and butter of the report, is the elements in here, and you know, the element name and the Revit ID and so forth. Now if I were to do this the hard way, let's do it from scratch. So yes, I'm still counting element keys. That doesn't change. But now I want to get the BIM document, file name. That's the first thing. Oh, already there's potentially kind of, you know, annoying issues. Okay, next I want the category tag. So I'm going to go into category tag. And then next I want the category name. So I'm still in category. I'm going to get the category name. And now I want the work set name. So I'm going to go into instance work set name. And now I want the family name. So I'm going to family name, and then I'm going to go into family type name. And then I can go back into my element to get the Revit ID. That was much more painful. If I actually close this down, we see that the information comes from 6 different tables. So instead of one table, we had to go all over the place. We had to walk to the market. We had to take the metro to go into 6 different tables to get the same information. So this little folder here called reference data prevents you from having to go all over the place. It's the same data. It's a duplication, but it's made for you. It's made to simplify things. So definitely use it, know how to use it. It's going to save you a bunch of time, a bunch of headaches, especially when you are beginning your journey. Okay, the last element in here is the supercomponent distance. And this probably deserves its own video because it's quite the thing. But basically, when we look at our element table, we're going to see what's the parent element. All the parents elements are zeros, and everything in a 1 is hosted in a 0, and everything in a 2 is hosted in a 1, which is hosted in a 0. So there's kind of a hierarchy in here. So you can have, let's go look at some good example. In here, in this plumbing fixture, we see this is the parent fixture, actually, with everything in here like this. So this is level 0. Well, actually, this is level 0. This is the thing that's inside of level 0. We call it, you know, super component distance of 1. And then inside of that, there's these. And then inside of that, there's these. So it's things inside of things, inside of things, inside of things. And so we see 0, 1, 2, 3. And this can keep going. And most importantly, this hierarchy, like notice how if I just select the top, all of the children are selected. So we've integrated that in basically the element hierarchy and the element embedded, but everything in your element list is going to have these things. And so how the heck do we use this? Well, we see in here, we actually drag the supercomponent distance as a column. So that's why we see your 0, 1, 2, 3 here as columns. So for example, in this list, if we only want to see the parents and none of the children, what we could do is say, make sure that the supercomponent distance is only 0. And now our list is shorter. If I want to make a list of only the third levels, well, we see third level is only these pipe systems, wherever they may be. So this deserves its own video because it's actually quite a new concept for us. The most important thing about all of this hierarchy is that it lets you select a single curtain wall and everything inside that curtain wall will be selected as well. So previously, or in most of our competitors, if you just select the curtain wall, you wouldn't get any of the panels. Whereas now, because we have this hierarchy, we can see all the panels and we can split them as part of this, line of parent and children, basically. Okay, we've actually gone through the entire element table. I know this was a super long video and I kind of got lost into a couple of micro topics, but I hope this was helpful for you. As I said, this is all available in here. So if you just want to go through your little cheat sheet, it's not going to go in as much detail, but I hope this kind of gave you some information as to what's going on in this scary little table, what you can ignore and what you should focus on. And most importantly, probably is just the concept of the key, the Revit ID, the reference data. And if you know these things, that's going to be the core of just getting started in your new report. So this is probably going to be the most complicated single table that we look at in the data model, but it's very foundational. So thanks for sticking with me. I'll talk to you soon. Have a great day. Cheers.